Bismillahirrahmanirrahim. Here's another concept in our study of ellipses in this chapter. So before you here is an equation for an ellipse. Okay, it's a perfectly good-looking ellipse. Okay, in this form: x minus vx squared over a squared plus y minus vy squared b squared equals 1. Correct? Where vx is 0. In other words, this is like x minus 0 squared over 49 plus y minus 1 squared over 9 equals 1. Correct? The center would be 1. The center would be 0 and 1. Okay, right? So this is a perfectly good-looking ellipse right here. So now what we're going to do now is we're going to kind of like mess it up. So why would you mess up a perfectly good-looking ellipse? Say, of course, for learning purposes, right? So humor me for a little bit and then observe the following, okay? So what I'm going to do is this, okay? X squared over 49, and I'm going to FOIL this, okay? So that's going to come out to be y squared minus 2y plus 1, like this, over 9 equals 1. And that is because, of course, you recognize that a minus b squared is a squared minus 2ab plus b squared. That's the difference binomial squared, like that. So we got that. Now what I'm going to do is I really want to like get rid of the denominators here. So I really want to get rid of the denominators here. So what I'm going to do is I'm going to multiply the whole equation by 49. So 49, that'll get rid of this denominator. And 49 here. So that way I get rid of this denominator. If I multiply everything by 49, I get rid of that denominator. And then I'm going to multiply everything by 9, as I don't have enough room over here. So 9 and 9. So that'll get rid of this denominator. By doing this, those two will cancel. This 9 will cancel with this, okay? So then I will have 9 here. So 9x squared plus 49 times the quantity y squared minus 2y plus 1. And 49 times 9 is 441. Okay, fair enough. Now what I'm going to do is I'm going to distribute this. Okay, so I have 9x squared plus 49y squared minus 98y plus 49 equals 441. Okay, that's pretty good. Now I'm going to subtract 49 from both sides. Take that to the other. And then I have 9x squared plus 49y squared minus 98y equals 392. So there you go. Now I have perfectly, I have ruined a perfectly good-looking ellipse equation into something that looks like that. The point of this exercise is to recognize that well, if an ellipse looks like that, of course you can recognize it. But what if the question is given to you in this form? Okay, now you should be able to recognize this, that this is actually also an ellipse. Okay, so how do we know that this is an ellipse? First, again, both the x and y terms are squared. Both the x and y terms are squared, and they are added together. Okay, so there's a plus sign over here. And that is the key in understanding that this is in fact a disguised ellipse. This is an ellipse that is disguised. Now, what I'm going to do now is I'm going to do an example where we are given an equation of an ellipse in this form. And then what we have to do is in fact change this into this form so we can graph it conveniently. Okay, so how do you go backwards? In other words, if you're given this ellipse in this form, and we're going to have to graph it, and so how do you go backwards in this process? And that's what we're going to do next, inshallah. Okay, so here we have it. So here's an example. Now you can see here that the x and y terms are both squared. So we're going to change this into the pseudo-vertex form like that. So how do we go about doing this? Okay, first we get all the x and y terms on one side. Okay, so I'm going to bring everything over here on this side. Okay, so got it? So that's the first thing I'm going to do. So that I do that, I get 2x squared, okay, and plus 8x, okay. I hope I'm not going too fast. What I'm really doing is I'm adding positive 2x squared to both sides like this, and then I'm going to add positive 8x to both sides like this, okay. So basically I'm taking everything to the other side. So then I have 2x squared plus 8x, so that's that side, and that's good. And then I'm going to take this y squared over here, and then I'm going to have plus y squared, and then I have the minus 16y plus 52 equals 0. Okay, very good. Now that's not so bad. So now what I'm going to do is we're going to complete the square. Oh, you thought you could forget. So complete the square. Okay, that was one of the 4 ways that we solved the quadratic equations, if you recall. You could graph them, you could factor, and you can complete the square, and then you could use the quadratic formula. So we learned to complete the square. So how do we do that? Okay, so what we're going to do is we're going to kind of separate ourselves, like divide this into 2 parts. Okay, I'm going to take this over there in the first place. Okay, so I'm going to take the 52 to the other side and give myself a working group. So I have 2x squared plus 8x, and then plus y squared minus 16y equals negative 52. So I've taken that to the other side. Now what I'm going to do is I'm going to kind of like think of the x's separately and think of the y's separately, like that. Okay, I'm going to divide them up into two mental compartments, so to speak. Okay, and so let me give myself more room. So there's a 2x squared plus 8x. I'm going to give myself some working room, plus, and then I have y squared minus 16y. Give myself some working room, so I have minus 52 over here. Now I'm going to complete the square for both of these, okay? If you recall from completing the square, the coefficient of the square term had to be 1, okay? So here you can divide everything by 2, but then this won't be 1 anymore. So what I'm going to do is I'm going to factor out a 2. So you're going to take that, factor out a 2. Then you have x squared plus 4x right there. And then here, I'm going to just leave it be. Y squared minus 16y, because it's already 1, equals minus 52. Okay, so what I did here was I factored out a 2. Okay, just from these 2 terms, because I'm looking at this, and separated them mentally into 2 different mental compartments. It's just x terms and then the y terms. Okay? So now I'm going to complete the square for here and then complete the square for there. So if you recall the way you complete the square, you take that, you take half of that, which is going to be 2, and then you add it, and then square this, and 2 squared is going to be 4, right? But then you have to add this 4 to both sides, right? So you just can't add a 4 over here. That's wrong, actually, because there's a coefficient there. So what you've effectively done, if you put a 4 there, is that you have added not a 4, but 2 times a 4. So you have to actually add an 8 on this side. Okay, it's very important to understand. What we're doing is we're completing this square over here. Alright? So to do that, you take half of the 4 and then square it and you add it over there. Okay? So if you do that, you have half of 4 is 2, square that is 4, so you add a 4 over here. But you can't just add something to one side of the equation, so you have to add it to the other side. But in effect, you have added an 8. You did not add a 4, you have added an 8, because it's just this 2 is going to be distributed, right? So you have to add 8 to this side. Okay? And over here, half of 16 is 8. Okay? And 8 squared is, this is half of 16 is 8, and 8 squared is going to be 64, correct? Now then you have to add 64 to this side, and that's not multiplied by anything because the coefficient there is 1, so it's just 64. Now you can complete the square, see? So it's going to be 2 times the quantity x plus 2 squared plus, this is going to become y minus 8 squared equals to, now let's do the math here, this is 72, negative 52 is 72, and that's 20. Okay? Now it's looking more like what we want it to be, isn't it? Okay, so now we have this. Now for an ellipse, if you recall, the equation is, okay, it's going to be x minus vx squared over a squared plus y minus vy squared over b squared equals 1. So we need to have 1 over here. Now after you've completed the square, you can divide everything by 20, see, like this, to get that 1. Okay? And when you do that, you have x plus 2 squared over, 2 goes in there 1 time, 2 goes in there 10 times, over 10, plus y minus 8 squared over 20 equals 1. And there is our equation for our ellipse. Okay? So there we have it. Now, and then you can see how you can graph this, and if you wanted to, you can say, well, this is a vertical ellipse because a squared, the bigger number, is under the y, so a squared is 20. This means a is square root of 20. This is 4 times 5. In the simplified form, this would be 2 times the square root of 5, right? And then you have b squared is 10, and therefore b is going to be square root of 10. That's it. It doesn't simplify, I think. And if you wanted to find c, you would say c squared is a squared minus b squared. A squared is 20, b squared is 10, so this is 10. Therefore, c is going to be square root of 10. And there we have it. Now you can go for it, and if you wanted to, you can easily graph this vertical ellipse. Okay, so in this example, what we did was we were given an opened up, and we shall soon talk about the standard form of this ellipse, an ellipse that was given to us like this, in this form, and it did not look anything like the general equation of the ellipse that we are used to, but we went in, we traced our steps, okay, and we got that into our general equation. And the way we did that is we got all the x's and y's together. And when we took the constants terms to the other side, and then we completed the square for the x's and we completed the square for the y's. Okay, and as a final step, we made sure that this was 1. Okay, so that's how you transform an equation of an ellipse that's not given to us in this vertex form, so to speak, and then you can able to graph it easily. Then, until next time, assalamu alaikum.